So I'm Steve Turnbull. I also work at Furtick Waterways Experiment Station, Coastal Hydraulics Laboratory, and introduced. So we're just going to kind of go over again. We're going to go through this display, and then we're going to work on an example in here shortly this afternoon, where you're actually going to build a basic GSSHA model. So what we're going to do here is just go through the steps, kind of the minimum steps to get your model created and get one running this afternoon. So everybody can hear okay out there? Yep. So just to go through the work steps, again, this was sort of summarized in the wizard. So gonna obtain all your data, your D land use, soils, mapping table, create your mapping tables, precipitation, whatever other data you had. Gonna delineate the watershed, generate a GSSHA grid. And there's basically one slide in this presentation for each of these steps. Set some switches on the job control to get the model to run. Generate your index map and mapping tables just for roughness. So in this particular model, we're going to create just overland flow to get it going. Define the roughness in the mapping table, give it some rainfall to run with, save and run. And then visualize these results. So as Chuck said earlier, you can build as much or as little complexity in your model, in your GSSHA model as you want. But this is kind of, this template is kind of the minimum what you got to do to get a model running. So first obtain your data, your DEM, your land use and soils, which is much easier to get now than it used to be. Then delineate your watershed. As the wizard step here, compute flow directions with Topaz, as we discussed earlier, just in the last presentation. Tell it to run, and then it will create this polygon, which is your watershed with an outlet. And this looks like that watershed up in outside Park City, Utah. The need, so you use the watershed basin polygon to create a grid. So the grid gets created, and you can specify. GSSHA uses evenly spaced cells. There's one grid size throughout the whole model. So you want to pick a grid size that gets enough detail in your model that you're interested in, but doesn't create more unnecessary cells. And oftentimes this will be driven or limited by your DEM. If your DEM resolution is 30 meters, there'd be no reason to create a grid less than 30 meters unless there was some feature, some tiny feature like a BMP that you're interested in looking at. And you're going to create some time intervals to get it started. In this particular example, you give it a slope. This one has no routing, doesn't have diffuse away routing in this example, and then hit some output, give it output control. There's a few defaults in there to get it running. Now, this is kind of the first time we're going to talk about creating an index map, which we did. Chris showed that in the wizard, but this is a very, very useful method and tool for creating GSSHA models. And when you hit to your index map, it's basically there's an integer associated or some sort of an ID associated with as much detail as little or as much detail as you really want in your model. And this particular one, so for soil type, for example, this particular example is for soil type. And it will give, there's what, 3 or 4 different soil types there. It will associate an integer with the red zone, the blue zone, the green zone, and the yellow zone. So most likely this index map is made up of 1, 2, 3, and 4, which represent those different regions of the map. And sort of the beauty of this is you can create as little or as much detail as you want in in your geisha model in the overland flow plane. And then for each of those, okay, in this particular case, there's 4 integers, 11, 14, 16, 5, 11, 14, 16, 21, and 41. Each of those integers is associated with that area of the cell. All the green area is 14, the integer is 14. And then you can, then throughout WMS, you can put descriptions in there and in the surface roughness or whatever parameter you're going to be looking at. And all those tabs above, roughness, interception. And we're going to, later on, as we do more tutorials, you'll click on a whole bunch of those different processes. And each tab on there represents a process in your geisha model. So it always starts off with roughness because you have to have roughness in overhand land flow plane, using land use typically. And then you're going to want to hit the generate AD button, which we'll do in a tutorial here, and it'll create, then you input your data for your index maps. Then to get the precipitation going, for this simple case, you can give it a uniform rainfall across the whole entire model. And then save your model, and then run it. And you can hit you've got roughness in there, you've got rainfall. You can go ahead and run the model now. You give a model a little run, and that's what we're going to do in the next tutorial. And the model wrapper will come up. Currently, the WMS says the release version of Geisha in it, which is very good to be using to start off with, for sure. Then, as visualize results to determine surface runoff problems, this is clean dam. This is getting some of the artifacts of the DEM smoothed out. Because your DEM will have errors, it'll have low spots that will cause it to look like that, uncorrected. And so you fix digital dams is one of the steps. Clean Dam is a program that goes through and helps smooth the DEM so that you get rid of those artifacts. Run through Clean Dam. Read the solution, and then so the spots, all the spots on the left, the black dots are now taken out on the right. You get a smoother map. It is if there's a certain feature. Sometimes Clean Dam will correct things you don't want corrected, so you might have to go in and undo some of it, what it does. If you know something about the watershed that that's there that got taken out as part of the process.
Let me jump in.
Yeah, sure, go ahead.
I'm the one that wrote Clean Dam. My name there. I'll be the person to say don't overuse it. Like it will eat channels across your watershed if you're not careful. Where you have stream arch defines, Clean Dam will ignore the problems that are there. So usually with the problems that you see all the little black spots there, in Geisha, we'll talk about this next, the flow algorithm we use is sort of a called 4-point, so north, south, east, west. You recall from the DEM exercise, the DEM flows all 8 cells. So where flow goes from one cell to on the corner, but neighboring north and south cells are higher, and that's where you get it. Usually they're not a huge problem. Sometimes if you're not careful, you'll see be like, oh, let me fix this, it'll be like big channels. Back up and try and fix it without having the big channel and stuff.
And that brings you, on almost any given model, you're going to have to go in and do some corrections to the DEM by hand in most models, and sort of my experience. Fix service border runoff problems, and then it looks much cleaner.
This here. Might be okay, but that'd be something you want to double check, make sure that's real and not clean that.
Okay.